antiderivative reverses the derivative process. So if we have the derivative here, sorry, I should be doing it this way. If I have f of x here and f prime of x here, differentiation is how I get f prime of x. And anti-differentiation, which is another word for integration, reverses the process. So you figure out what your original function was, okay? So capital F prime of x is an antiderivative of the function f of x because capital F prime of x equals f of x. So find the derivative of 6x to the power 5. So picture in your head, what would I have to start with to get a derivative of 6x plus 5? Oh, sorry, 6x to the power 5. I'm sorry, Caitlin? X to the power 6, very good. Anything else?
6 to the 5.
That's the only thing? Okay. Nobody can think of another one? Another form that would give me a derivative of 6x to the power 5? Yes, so x to the power 6 plus 5, x to the power 6 plus 1,000. Any constant would actually work. Do you remember the video I showed you? They were singing, add a constant, add a constant. Don't forget the constant, yeah? Okay, so therefore, capital F is the antiderivative of f, then all other antiderivatives of f have the form x to the power 6 plus c, where c is the constant. So basically this was plus 0, right? Do you see all of these have the form x to the power 6 plus some constant? Okay, so find the antiderivative of those now. See if you can figure it out. Yeah, that's what I'm saying. Now we're reversing it. So now. Okay, so I heard 1 over 4 to the x to the power 4 plus c, right? So think about this. To find the derivative of this, the 4 would get multiplied by 1/4, and you'd get 1, which there's a 1 there, and then this would go down 1 number. Okay, what about the next one? Shh. Okay, did everybody have a chance to figure it out? Okay, what is it? Huh? No, it's not 1/2 x. It's what? 2x? No.
2/3 x to the power.
It's actually 2/3 x to the power 3 over 2 plus c.
Don't forget the constant.
Don't forget the constant. That's a 3 over 2 in the exponent. Okay, how about this one? This one's probably easier. What would that one have to be? Yes, 1/2 x to the power 2. So again, find the derivative of this. You'll see you get x out of that, right? Plus c. Okay, next one. I would write this one first as 2x to the power -5, so it's a little easier to figure it out. This one's the epitome of whether you know what to do.
-1/3 x to the power -6.
No.
No, it's -4 first, you're subtracting 1. So the original
I
x to the
subtracted
power 4.
Yes, you're subtracting 1. That's right.
So if you're multiplying that and -4, so you have -1/2.
Yes, -1/2. Okay, so how does people know? I'll give you some formulas. It's not as hard as you think. So anyways, if you have Thank you. If you have some constant that you start with, what would be the original function? So after you found the derivative, it's k. So what would have been the original function? Kx. Does everybody see what would be kx plus c? Okay. So now here's the actual formula for the power rule. So you know how you had the derivative and you took that power, you multiplied it to whatever's in front. What would be the inverse of multiplying it by whatever that is? Dividing it. Or, so we don't do division really. We do multiply the reciprocal. Yeah. We're going to take the reciprocal and multiply it. But you have to add 1 to that first. Yeah, so it's going to be 1 over n plus 1 times x to the power n plus 1 plus c.
So n is just like n in this situation.
Yeah, so for instance over here n was 3, so I added 1 to 3 and I got 4, so then I got 1/4 x to the power 4. In this case this was x to the power a half, so if I add 1 to a half I get 3 over 2, so the reciprocal is 2 over 3 times x to the power 3 over 2. Does that make sense to you?
Oh yeah, because it's 1/2. So it's broad.
Are you talking about this one or this one?
No, like the x power 1/2. You're saying like
X to the power 1, so I add 1 to 1, that's 2, and it's the reciprocal of 2, so 1/2.
I was talking about for like the reciprocal of
You have to add 1 to 1/2 first, then reciprocate it, yeah. Okay, sine x. So this one, kind of use your common sense of what it would be. The derivative of what gives you sine x? It would be actually negative cos x, yeah. Because the derivative of cos is negative sine, so in order to get positive sine, it must have been a negative cosine.
It's all a big circle. Like
It is it's all a big circle. So then what about this one? Trig is the most confusing, especially sine and cosine, because you think you're doing derivatives when you're really doing the other way or whatever. Okay, what derivative gives you secant squared x?
Wait, is the derivative kind of negative?
No, that one doesn't have negatives. The CCC is negative, right?
Oh, the SST thing still holds up for spin.
Oh, before I go on, there was an exception here when n was negative 1. You can't use this rule here.
what do you use?
Because what is when x is negative 1? X to the power negative 1?
Oh, so you're gonna get
That's 1 over x. Does anybody remember what derivative gives you 1 over x? Yeah, that is the ln of x there. So it's actually the ln of the absolute value of x, because it has to be positive in order to find the logarithm of it. So, anyways.
so it's not gonna. What happens if you see an exponent?
No, we will bring that into everything.
So you're
Yeah,
saying like you can put it out.
I should actually have it in there. Did I add it to my table? Yeah, I did. Right there. I just don't have it here. Okay, so what derivative gives you secant tan? Secant x.
So I still hold up. That's awesome.
You didn't have a tan x?
Yeah, you had a tan x, we didn't have a tan.
Oh, interesting.
Like, go back to the last page.
I'm looking at Josh's and he has a secant squared.
Oh, it's secant square. Oh, never mind. Sorry. Oh, yeah,
I know, it goes on different pages. Sorry about that. Is everybody good with this page so I can go to the next page? Okay, what derivative gives you cosecant squared? But not just cotangent. No. Negative cotangent. Remember the and the minus CCC? So if that's positive, the other one has to be negative, right?
That's nice, but this is all the same way.
Okay, what about cosecant cotangent? Negative cosecant x. Okay, who remembers this one? This is inverse sine of x. Does anybody remember the next one?
Inverse.
Inverse tan of x. You notice I didn't give you all the other ones. This is the most common ones. And so how about e to the power x? The derivative is itself, right? E to the power x plus c. And then this is the one I already talked about. Because if you actually, this is x to the power negative 1. If you add 1 to negative 1, you get 0. And so that should be the red flag. Ooh, that's the one. Yeah, the formula doesn't work. This is the one that is the ln of the absolute value of x plus c. So you need to put these on your recipe cards or whatever you have. And start memorizing these, right? So it is pretty easy to check your answer because you just have to take the derivative of your answer and see if it actually gets you to where you start with. So for instance, the derivative of secant is secant tan. You know what I mean? So if you're not sure if you're remembering the sign right, do the derivative of what you got and go backwards, right? Okay, so find the antiderivative of x squared plus 1 times the square root of x. So this is huge here. You know how we had the product rule for differentiation? No such thing for integration. Integration is very picky. There is no product rule. So you know how if I were to find the derivative of this would be f prime g plus f g prime. Remember all that? So anybody have any clue of how we could do this?
Multiply it in.
Yeah, you actually, and I always told you if you can actually simplify things easier, it's much easier. So multiply this first. The square root of x is x to the power of half. So what's x to the power of half times x squared? X to the power? You add the exponents. 2.5, which is 5 over 2, plus x to the power of half. Not 5 halves, 5 over 2. Well, I guess the same thing as 5 halves, yeah. Okay. Anyways, so I still have to find the antiderivative. I just simplified this, right? So you're supposed to add 1 to that. So what's that? 7 over 2. Reciprocate it, so it's 2 over 7, x to the power 7 over 2. Add 1 to that. Sorry, 3 over 2, so 2 over 3, x to the power 3 over 2. And don't forget the constant. Don't forget the constant. Yes. And then you'll lose marks, right? Well, okay, so all the physics people, here's your physics application. What's on the far left here? S, or distance, right? Yeah? What's the derivative of distance? Velocity. And the derivative of that is acceleration. Okay, so then going the other way, do you see? We're going to be doing that. So a rock was dropped from a height of 1,000 meters. If the rock accelerates towards the ground at a rate of 9.8 meters per second squared, does that ring a bell? That's yes, acceleration due to gravity. How long does it take to hit the ground? All right, let's figure this out. So what are they giving you when they gave you that a rock is dropped from a height of 1,000? Very good. So when V equals 0, S equals 1,000? That's what they're telling you there. Does that make sense to you? Okay. What are they giving you when they gave you 9.8 meters per second squared? Huh? acceleration is, and by the way, if it's towards the ground, it is a negative.
But in physics, negative signs are kind of useful. You don't use them all the time, but you kind of use them sometimes.
Depends on,
Yeah.
yeah, okay.
Yeah. If you're saying it's going downward, then you don't put the negative. But if you're saying it's a negative and no direction with it, then it's just a negative.
Okay,
Since they said towards the ground, that's what they're going to make.
so what can we do here? Oh, you know what? When t is 0,
It's at a height of 1,000.
it's at a height of 1,000 as well, right?
Yeah, because acceleration.
Okay, so, and maybe we're going to use t equals 0 versus v equals 0, depending on, oh, it gives me a hint. When t equals 0, what do you know? This is what you know, all of that, right? Okay, so if we know acceleration is minus 9.8, what can we say? Velocity is so there's a t to the power 0 essentially there. So what is it?
Accelerate.
What are you saying? Okay, so what's the velocity equal to? Minus 9.8 t plus c. Is everybody good with that? Why is it t and not x? Because usually we talk about time when we're doing a physics problem, right? Okay, so here's our first kind of introduction to differential equations. In order to actually find how long it takes to hit the ground, we actually have to figure out what c is.
But isn't
C would be 0. Why would c be 0 in this case?
Because the velocity at 0.
Do you see sub 0 in for velocity, we get 0. Sub 0 in for time, we get 0 plus c. So that means c equals 0. So that means I can now rewrite this as v of t equals negative 9.8 t. So now we're going to find the antiderivative of that. So what's that? S of t, yes? What's that equal to?
9.8 over 2 times t squared.
So what's negative 9.8 over 2? Negative 4.9 t squared plus c. So we come into a little bit of a conundrum. Well, not really a conundrum. Oh. So, I'm sorry? How long does it take to hit the ground? Because the distance is 0 then, right?
So would you need the c in there so it's 0?
The c here, so this is my conundrum. We have another c. It's not the same c. So we're going to call this C1 and C2.
But for this one, can't you just plug in 1,000 and 0 and then you get what C2 is?
Yes.
Yeah. Or just wouldn't C2 be 1,000? Because it's going to be 1,000 equals 0 plus C2.
1,000 equals
0 plus C2.
Yeah. This is where you can see the physics people have a little bit of an advantage, right? So do you see that C2 would be 1,000 then? Yes? Yeah? We're good? So that means S of t equals negative 4.9 t squared plus 1,000. So now we need to know how long does it take to hit the ground. So that means it is, does everybody know when it hits the ground the distance would be 0? So if I move the 1,000 over, I get minus 1,000 equals minus 4.9 t squared. And if I divide, okay, we're going to get our calculators now because this is now past the point of non-calculator. Yeah, actually, so somebody mentioned you don't have to memorize any physics formulas anymore. Well, no, like you can just derive it all yourself, right?
Oh, we can.
So, T squared is approximately 204.08. So T is going to be plus or minus. I hear that every time I teach this part where the physics people are like, oh, it makes sense now. Where's my square root button? Oh, there it is. Oh. Yeah, so we're going to reject that. Except that I gotta, my calculator isn't, well, blah, 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 blah. I should, 204.0816, blah, 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 blah. So, the square root of the answer. So, 14.2857. So, therefore, at 14.2857 seconds, it is at ground. Yes? Make sure you have your units in there, all that.